All right, let's do a little bit of accounting. So I'm going to go back to my overview. I suggest you write this kind of a little bit separate in your notes instead of on the overview, but we're going to do some accounting here in red. And our accounting is going to be what exactly have we made energy-wise. So we have made 2 ATP in glycolysis. We've made 2 ATP in the Krebs cycle. We sent a lot of electron carriers over here. And it turns out that for every NADH that goes through and drops off its electrons, you make 3 ATP in the electron transport chain. And for every FADH2, you're going to make 2 ATP. Now, let me bounce back to my electron transport chain just for a minute here and point out why the lesser number for FADH2. And I probably should have made this a little bit more clear here. FADH2 doesn't actually dump off at the beginning of the electron transport chain. It dumps off partway through. So FADH2 contributes its electrons a little bit later on in the process. All right, so every NADH makes 3 ATP, every FADH2 makes 2 ATP. So if we do our accounting here in glycolysis, we made 2 ATP separate by themselves, 2 net ATP, and we made 2 NADHs. Times 3 gives us a total of 6 ATP, right? So those would have been made in the electron transport chain. And then we had the Krebs cycle, which made a net of 2 ATP for 1 glucose. This is all for 1 glucose. We had 2 ATP, and we made a total of 8 NADH2, and we made 2 FADH. Sorry, made a mistake. 8 NADH and 2 FADH2. So our 2 ATP, great, we count those from the Krebs cycle, and then our 8 ATP, our 8 NADH are multiplied by 3 to give us 24 ATP. And our 2 FADH2 are multiplied by 2 to give us 4 ATP. So all in all, our electron transport chain has produced 34 ATP. In combination with our 2 glycolysis and our 2 ATP, our sum total is 38 ATP made through aerobic respiration. So our sum total, our aerobic cellular respiration, results in 38 ATP. Now, this 38 ATP, sometimes you'll see individuals or scientists say that it's only 36 ATP. So 36 to 38 ATP. There's argument over whether or not 2 more ATP are used in this process in the breakdown of acetyl-CoA. But to my knowledge, they haven't settled that argument. So you're going to be thinking about the production of ATP as 36 to 38 ATP.